All right, we are back. This is Techmath1. We are looking at chapter 13. We're going to do a problem from 13.7 in the applied problems. We're going to do number 55. So right near the end, 55, on page 574 in the blue book. So let's take a look. It's a mixture problem, and these are very common problems from algebra. So if you came from algebra, you've definitely seen these already. If not, I will explain them to you. So solution A is 30% alcohol, solution B is 80% alcohol. How much of each is needed to make 100 milliliters of a 70%? So think about this. We got 30% stuff and 80% stuff, and they want 70% stuff. So it's going to be mostly the 80% stuff, and we're going to just kind of water it down a little bit with the 30% stuff to get it to be 70%. But now, how much of each is the question? And it sets up as a system of linear equations. So anytime you're working a mixture problem, you've got x plus y is equal to the desired amount. In this case, they said 100 milliliters. All right. Now, that's always the first kind of set equation. The second set equation, you kind of use this again as framework. Only what we're going to do now is we're going to put in the percents. So they said you got 30% solution, so that's going to be multiplied by our x. Okay. They said you got 80% solution. So that's how much of y. So y is going to be how much of the 80% stuff. X is going to be how much of the 30% stuff. And this is a part a lot of people forget. So don't forget this part. You're trying to get a 70% solution. And so you write that down. X plus y equals 100. That's the mixture part. And then this is the percent part. Okay? Where you just put each percent down for each value. So now if we take this and kind of do a rewrite down here, we got x plus y equals 100, and you got 0.3x plus 0.8y equals 70. And now you can do it however you want. If you want to do substitution, we could solve for x or y and sub it into that. If you wanted to do what they said to do before, like multiply everything by, in this case, it would be 10, because these are tenths, to get it to be whole numbers before we start, we could do it that way. Let's do it that way. So 10 times everything will get rid of my decimals. So I'll have 3x plus 8y is equal to 700, and x plus y equals 100. All right, so I didn't change anything in there. Now we want to get rid of the x's or the y's. Let's get rid of the x's. So if we want to get rid of the x's, this stays 3x plus 8y equals 700. But this, I've got to get rid of the x, so I want a negative 3x there. So I multiply everything by negative 3. So negative 3x, negative 3y equals negative 300. I add straight down, I get 5y, right? The x's die like we wanted them to. 5y is equal to 400. And then I divide by 5 both sides. So y is equal to 80. So 80 milliliters of y is the 80% solution. And then how do we find x? Well, you take the 80 and you put that in. So x plus 80 equals 100. Or you just use logic and go, look, you got 100 and we got 80 of it, so it's got to be 20, right? So 20 milliliters of the 30% solution. which does make total sense that this would mostly be most of it, because it's really 80 is closer to 70 than 30 is to 70. So we just have to add a little bit of the 30% stuff to kind of water it down to get it to that desired 70%. All right. That is called a mixture problem. There's a lot of different variations on those. Like if you've ever seen problems where it's like 2 different ticket prices to get into the theater and stuff, it sets up the same way. All right. So that was 13.7. Let's take a look at a problem from 13.8. So that on page 577, if you take a look at 61, that's a good problem. That's another applied problem. And a voltage of 32 volts is applied to a circuit consisting of 2 parallel resistors of 10 ohms and 40 ohms, connected in series with a 30 ohm resistor. We want to find the currents in the 10 ohm and 40 ohm resistors if I sub 1 is the current in the 10 ohm and I sub 2 is the current in the 40 ohm. We can use the basic circuit principles, solve for I sub 1 and I sub 2. Okay, so really this is just 30 I sub 1 plus I sub 2 plus 10 I sub 2 equals 32. And 10 I sub 1 minus 40 I sub 2 equals 0. So they already did all of the electrician calculations for us with the setup. So we're just going to do the algebra part. So that means you do the distributive property. We get 30 I sub 1 plus 30 I sub 2 plus 10 I sub 2 equals 32. And then we combine like terms there. Nothing for that one, but those two can go together. So 30 I sub 1 plus 40 I sub 2 equals 32. And then leave that one, 10 I sub 1 minus 40 I sub 2 equals 0. So this worked out very conveniently in that if we add straight down right now, the I sub 2's will go. We'll get 40 I sub 1 is equal to 32, and then divide by 40. So I sub 1 is going to be 0.8. When you take 32 divided by 40, and then you can take that 0.8 and put it into this equation. So 10 times 0.8 minus 40 I sub 2 equals 0. So what is that? 8 minus 40 I sub 2 equals 0. And now isolate the variable, so subtract 8 from both sides. So negative 40 I sub 2 equals negative 8, and then divide by negative 40, and that's 1/5 or 0.2. So I don't know if there's any electricians in the crowd, if that always has to be 1 or something, or if it was just coincidence that it happened to be 1. But that's how it works out. So 0.8 amps for I sub 1 and 0.2 amps for I sub 2. All right. Okay, let's look at 13.9. I think it's really cool that the algebra fits nicely in with all of these different careers that they use, you know, that algebra, that base language. It's I'm very used to teaching abstract, like algebra class. It's very abstract, and the real life problems they have are so phony a lot of the times. Where these are not. These are very, very realistic. These come from, pulled right out of the real world and tied into really nice algebra problems. So let's take a look at 63. The formulas form a system only if they contain one or more common variables. Okay. So state whether each pair of formulas below forms a system or not. Okay, so this is number 63 on 13.9. That's on page 579 of the blue book. So this has H equals capital M over T and AT equals V. So see, they both have this the small letter T in it. So this would be a yes. They have a common variable, T. T is common to both of them, which means you could play one into the other with substituting. This one, letter B, says S is equal to 0.26 dn. And the other one says little v is equal to gt. There's no overlap there, so that would be a no. We couldn't use those as a system because they don't have a common variable. And then the last one, letter C, they have F equals MA. They have F, well, clearly this one is because there's an F, right? G, R squared and M, so that's a double whammy. So that is a definite yes. We could do a system with those. All right. So now let's look at what we can do with that in 1310. Where we can do tie-in here, number 68, they give us, oh, that's an S, not an A. Jeez. S is equal to B plus T, and then they give us B is equal to 2S plus V, and let's see what they tell us to do. It says use the same method to, they want us to eliminate B and solve for T. So let's write that down. They want us to eliminate B and then solve for T. Okay, so this B is already solved. So what we could do is we could take this and sub it in, do the substitution method to get rid of the B, basically. We substitute it away, because now look, we have S is equal to plus T, and normally it was B plus T, but instead of B, we're going to put in 2S plus V, all right? And so now, forget about the system, because we've already eliminated the B through substitution, and now we just want to solve for T. So this is what we have. We have S is equal to 2S plus V plus T, and it's all being added, so really all we have to do here is subtract off the minus 2S and subtract off a V, minus 2S, minus a V, and that should get us our answer. So 1S minus 2S is negative 1S minus 1V. And it's likely they don't have the ones there, so they probably just have negative S minus V equal to T. It's fine. I don't care on your answers if you give me a 1 in front of it. The 1 is there whether you write it there or not. And it wouldn't matter if you said negative V minus S either. The order doesn't matter. All right? Okay. So let's see what else. 1311, the equivalency method formula. All right, so let's look at one of those. 1311. So we got, which one did I want to do there? 79 on page 587. in the blue book, 79. So here goes. Let's use the equivalency method to eliminate B from the system and then solve for C. All right. So here, these are the equations. They gave us H is equal to B over KT. They gave me A is equal to BC. And they want eliminate B and solve for C. Okay, so basically they're saying the equivalency just means it's a substitution. You're still doing substitution. It's just you're solving for B on both of them and then subbing one into the other. That's all. So it's a pretty easy process here. In this case, we would cross multiply and solve. That would solve it. It would be B is equal to HKT. So that's what that ends up being. This one is pretty easy to solve for B. You just divide both sides by C. That wipes that out. And so we end up with B is equal to A over C. And they make it sound like this is some big new thing. It really isn't. And now they're saying, now do the equivalency method, which is just meaning I'm just going to take this and sub it into that and get rid of B. I could have done that without actually isolating the B. I could have just taken this and put it in right there, and it would have been the exact same thing. But they wanted us to solve for B, solve for B. I guess as far as maybe organization, that might help some students, like to have it kind of organized like that. But it isn't essential to do it that way. It's just a different method. So here we are. We have A over C is equal to HKT. Lots of letters. And now they want me to solve for C. So this is what we're going to do. We're going to cross multiply and solve. So we have HKTC equals A. And if it were 5C equals 10, something like this, a lot easier with numbers, you would just divide both sides by 5, and then you'd have C is equal to 2. It's more abstract than that. It's HKTC equals A. So we're still going to just do what we did there, where we divided by 5, divided by 5. We're going to divide by HKT and divide by HKT. And so C is now equal to A over HKT. So we eliminated B and solved for C. And again, I think that actually added a step. We could have just solved for B here and then taken that and put it right there, and that would have put us at this step already. You know what I mean? Instead of doing those extra two. But if it helps you to understand it that way, totally, you can do it that way. It's fine. All right. And then that is it for chapter 13. The next part, we're going to do chapter 14. I'm going to show you how to use your graphing calculator in chapter 14.